geologists are coming as they're trudging down the hill. When they say that mountains young, they're talking 10 to 20 mil. They're classifying rocks from destruction to rebirth. The geologists are coming, they're converging on the earth.
Hello friends, and welcome back to Geology Time with Mrs. Mel. How's everyone doing? Cool, my name is Mrs. Mel. Today we are reading chapter 6 of our geology book, and today's chapter is very exciting. It's something I love very much. It's rocks. I love rocks. And we're going to learn about the different types of rocks today. So get your geology book, your scissors, your pencil, your glue, it all. Grab a rock if you have one to keep you company, and let's get started. Okay, chapter 6, Earth's building blocks. How can changes in rocks over time be explained by the rock cycle? You don't have to look hard to find rocks. They are all around you, and under you too. Earth's crust is made almost entirely of rocks. Mountains, hills, and cliffs are huge masses of rocks that form landscape features. Pebbles in a stream bed are smooth, rounded rocks. Chunky bits of broken rock form the gravel on a country road. Rocks go into making sidewalks and streets. Slabs of rock cover the outside of many buildings. Indoors, pieces of rock often make up floors, walls, stairs, and countertops. Museums are good places to see rocks that artists have carved into sculptures. The polished stones in some types of jewelry are rocks that people wear. Rocks are all around us. Wow! There's a kid. Rocks and building blocks. Just what are rocks exactly? Rocks are naturally occurring materials made of solid, non-living substances called minerals. Think of minerals as the building blocks of rocks. Some rocks are formed from just one mineral. Most rocks, however, are combinations of two or more minerals. Minerals appear as different-sized pieces or grains in rocks. Some rocks have very tiny mineral grains, giving the rocks a smooth, even texture. Other rocks have larger mineral grains and a rougher texture. Imagine hiking up a mountain and picking up rocks along the way. When you reach the top, you'll probably have quite a collection. It's true, it makes your backpack very heavy. Your rocks may have different colors and textures. Some may have stripes or layers. Some might be hard or others crumbly. Some have tiny grains, whereas others have large grains that glitter when they catch the light. All this variety might seem confusing, yet geologists organize all rocks into just 3 classes or basic types: igneous, sedimentary, and metamorphic. Those are 3 important words that you need to know.
Igneous, metamorphic, sedimentary, 3 types of rocks, and that's all 3. Say 3 types of rocks, and that's all 3.
Born from magma. Igneous rock. So let's start with igneous rocks, the most abundant class of rocks on the Earth. Igneous rocks form when magma cools and solidifies. When you think of igneous rocks, think of volcanoes. There are 2 basic types of igneous rocks. One type forms from magma that erupts onto Earth's surface as lava. The lava cools and hardens into rock. The faster it cools, the smaller the mineral grains will be in the resulting rock. The second type of igneous rock forms when magma that solidifies below Earth's surface. Magma cools very slowly when it's deep beneath the surface. Slow cooling leads to igneous rocks with relatively large mineral grains. The slower the cooling, the larger the grains.
Igneous rocks are formed when magma from a volcano cools.
Ingenious how magma fills and puddles up in pools. Igneous rock is made when molten magma cools.
Next type of rock. Layer after layer, sedimentary rock. Sedimentary rock is the second major class of rocks. Sedimentary rocks are made out of sediments. Sediments are tiny bits of rock and sand combined with fragments of once living things. Sediments collect in low-lying areas, both on land and in bodies of water. They form layers, one on top of another. Over long periods of time, the weight of overlying layers compacts the sediments in deep layers, squeezing them closer together. Sediments also become cemented or glued together as dissolved minerals fill the spaces in between the sediments. As the sediments dry, the dissolved minerals turn into solids, binding the sediments together. Over time, compacting and cementing processes transform sediments into sedimentary rock. Most sediment rocks are more easily broken than most igneous rocks. Hit a sedimentary rock with a hammer and it will crumble or break apart. Some sedimentary rocks contain fossils.
Sedimentary rocks form when eroded earth and other materials settle in layers. These layers press down over time to form solid rock.
Thought I'd never say it, but I guess it's meant to be. Layered rock and other rocks with sedimentary.
All right, the third major class of rocks is metamorphic rock. Metamorphic rocks form when igneous or sedimentary rocks are exposed to extreme heat and pressure. They can even form from older metamorphic rock. High temperatures and crushing pressure alter the minerals in the rocks. Minimal grains may be flattened or rearranged into layers, swirls, or stripes. They may also be changed into completely different minerals. Metamorphic rocks tend to form deep within Earth's crust. The pressure from countless tons of overlying rock is tremendous. Equally powerful is the heat rising from hot magma in the mantle beneath the crust. Metamorphic rocks often form where tectonic plates are slowly colliding. They can also form as magma travels up through cracks in Earth's crust and heats the rocks around the cracks. If the heat of the magma completely melts the rock again, then it becomes igneous rock. If the rock is heated just enough to be changed, however, it instead becomes metamorphic rock. So molten rock, heat, metamorphic rock, pressure from weight of rock layers and Earth's surface. Fascinating!
Metamorphic rocks are igneous or sedimentary rocks that have been changed by high temperatures or pressure. For example, the folds in this metamorphic rock were caused by extreme pressure.
If you've never met a metamorphic rock, you can't be blamed. Always changing over time, never stays the same.
Rock cycle. Last page. Rocks you can see in the world around you might seem like permanent features. Given enough time, however, all rocks change. They are created, destroyed, and recreated in a continuous cycle. Geologists call this ongoing process the rock cycle. The rock cycle has no starting or ending point. You can jump in anywhere to see how it works. Let's begin with magma erupting from a towering volcano. The magma, now lava, cools and hardens into igneous rock. Over the course of thousands of years, sun, wind, and rain and freezing temperatures cause the rocks to weather or break down into smaller pieces. The pieces continue to weather, slowly breaking down into sediments. Howling winds, flowing water, and gravity gradually move the sediments down the sides of the volcano and beyond. Movement of sediments from place to place is called erosion. We know that. Imagine that the sediments end up in a lake where they settle to the bottom. Over long periods of time, more layers of sediments are deposited on top of them. Compacting and cementing processes eventually turn the deeply buried sediments into sedimentary rock. Now imagine that the sedimentary rock is near the edge of a tectonic plate. The plate collides with another plate, very slowly, of course. Tremendous heat and pressure generated by the collision gradually turn the sedimentary rock into metamorphic rock. As the plates continue colliding, their rocky edges crumble. The metamorphic rock is slowly pushed up higher onto Earth's surface, think mountains. Exposed to air, rain, and snow, the rock begins to weather and erode. Alternatively, one tectonic plate might be sliding beneath another. The metamorphic rock along the edge of the descending plates gets hotter and hotter as it nears the mantle. At some point, it melts into magma. Magma that might someday erupt from a volcano again. Understanding how rocks change helped geologists understand how Earth has changed over time. Hey, I've seen this picture before. Yeah. So there we have igneous rock to sediments to sedimentary rock to metamorphic rock to magma, or igneous rock to metamorphic to sediments. Interesting. Cool beans. Okay, here we are on page 6 of our geology book, and we just read chapter 6. We're skipping chapter 5. The cause, rocks are created, destroyed, and recreated in a continuous cycle. The evidence of that is the rock cycle and the 3 types of rocks. Okay, let's look at page 9 to figure out which picture we want to glue it right there. But I think I already know what picture I want to glue right there. Okay, let's turn to page 9. Okay, so this is page 9, and we just used this one last for chapter 4. Do you see a picture that was just in our book? So we have seafloor spreading, mountains and lakes, Grand Canyon, or, you know this picture? Ah! Yes, it's this one right here. So letter I. Okay, turn back to page 6. Let's put a letter. Okay, so letter I. Letter I, and the picture of the rock cycle right here. So yeah, the cause is that rocks are created, destroyed, and recycled in a continuous cycle. And the evidence of that is the rock cycle and the 3 types of rocks. Cool. All right, good job, friends. Thanks for joining me as we talked about the rock cycle I think it's fascinating. Now, if you're paying attention, any rock that you pick up, you'd be able to classify as one of the 3 types. You'll learn a lot more about this in 5th grade and beyond. I remember in middle school, they had like rocks everywhere, and we had to say what of the 3 types they were. So it's really interesting. Yay! I love rocks so much. It's the building blocks of the earth. It's history right in your hand. It's so cool. Okay. I love you. You're also cool. And I'll see you next time. Take a picture for Seesaw. Bye. Rock on.
There's 3 types of rocks in geology. Geology types in geology. Geology